Let's do our last two example problems in this section. Now, for number 10, I'm going to have you rewrite this a little bit to help you out. We're going to start by taking that 3 and moving it outside the integral, which we know we can do. Second, we know that 3 times 2 times 5 is the same thing as 2 times 5 times 3. Anytime there's multiplying, we can totally move things around and it's okay. So what I'm going to do is move this theta to be by the d theta. So I'm going to put the cosine first, and I'm going to add parentheses around that theta squared so we see it a little better. And then do the theta d theta. That's going to help you see your du a little bit better. So once again, I would like you to pause the video from here. Using that knowledge, remember that u is usually what's on the inside. So start with that and try to solve this problem out on your own. Ready, set, go. Come back, let's see how you did. So this is our inside, that's going to be our u is theta squared. Take the derivative of that, and I just already moved the d theta over. So now I'm going to start to rewrite things. I got my cosine of theta squared, my 3 on the outside. I noticed that I need a 2 right there to make my du match. So I put the 2 in there, put the 1/2 to balance it. So I've got 3/2 cosine of u du. That du says we should all be in the variable of u, which we are, check. So integral of cosine is sine of u plus my constant of integration. And then I plug my u back in, and there we go. Let's try number 8, last one. Okay, I'm actually going to do this one with you because it's a little weird. Now, usually what's on the inside is our u. So we're going to say u equals y cubed plus 1. So then du is going to be 3y squared dy. Now, if I go to rewrite this, I could add that 3 and the 1/3 to balance it, so I get the 3 and the dy. However, I cannot add a y squared and a 1 over y squared. I can't add letters to the outside. I can only add numbers on the outside of the integral. So adding that y squared in so that our du matches isn't gonna work. So the trick to this one is it's not actually a u substitution problem. U substitution doesn't work on this problem. However, if I go back to this, it's y cubed plus 1 squared, which is just times itself. I can actually multiply this out. That's not too hard. I would get y to the 6 plus 2y cubed plus 1. And then I can just do this power rule wise. So the integral of y to the 6 is going to be y to the 7th over 7 plus 2. Integral of y cubed is going to be y to the 4th over 4. Plus the integral of 1 is going to be 1y, or just y, and then plus my constant of integration. And that's it. So even though this problem looks like it should be a u substitution, it actually isn't. And that will happen sometimes. You got to be really careful with those problems. Okay, in the last video of this section, we're going to talk about one other example problem of u substitution that gets a little trickier than what we've been doing.